Hello everyone, welcome to lecture 3 of CIN603 System Analysis and Design. And in this lecture, we shall be looking at managing systems projects. Moving on, we will be looking at the chapter objectives. Now, the objectives of this lecture is explain project planning, scheduling, monitoring, and reporting. 2. Describe work breakdown structures, task patterns, and critical path analysis. 3. Explain techniques for estimating task completion times and costs. 4. Analyze task dependencies, durations, start dates, and end dates. 5. Describe project management software and how it can assist you in project planning, estimating, scheduling, monitoring, and reporting. 6. Discuss the importance of project risk management. And finally, understand why projects sometimes fail. Introduction. You will learn about project planning, estimating, scheduling, monitoring, reporting, and the use of software management software. You'll also learn how to control and manage project changes as they occur. Now, project planning is a part of project management. It relates to the use of schedules such as Gantt charts to plan and subsequently report progress within the project environment. Project planning can be done manually or by the use of a project management software. Overview of project management. Now, project management, it is a process of leading the work of a team to achieve all project goals within the given constraints. This information is usually described in a project documentation created right at the very beginning of the development process. A successful project must be completed on time, within budget, and deliver a quality product that satisfies users and meets requirements. Project manager or project leader. A project manager is responsible for day-to-day management of the project and must be competent in managing the 6 aspects of a project. And these 6 aspects include scope, schedule, finance, risk, quality, and resources. Project coordinator. A project coordinator is a professional who is often involved in the day-to-day operations of the assigned project. They organize and communicate details related to a specific assignment or task while serving as an interface between team leaders and managers. Generally, a project coordinator reports to the project manager. Overview of project management. What does a project manager do? A project manager may also be called as a project leader, and the tasks that they perform are planning, scheduling, monitoring and controlling, and reporting. To plan, that means you need to clearly list down what work will be performed at what time. And to do this, one of the first things that a project manager could do is to create a work breakdown structure. Now, a work breakdown structure involves breaking a project down into a series of smaller tasks. Before creating work breakdown structures, you should understand the 2 primary types of charts that are used to enlist the tasks involved in a project. One is Gantt chart, and the other one is PERT or CMP charts. PERT or CMP charts, we'll be looking at those in the later slides. A Gantt chart, what is it? It is a task group, can represent an overview of the project's status, but does not provide detailed information that is necessary when managing a complex project. The Gantt chart was initially designed by Henry Gantt around the years 1910 to 1915. It is a type of bar chart that illustrates a project's schedule. And you may notice a Gantt chart in the diagram that is presented in the slide at the moment. So like mentioned, a Gantt chart illustrates the project's schedule. So you will see right on the very top, you have the dates given in. So from August till November 22nd. And corresponding to the time, you have the set of tasks that must be completed. The milestones represented by the yellow X sign, the purple star sign, and the orange triangle. These are some of the short achievements or deliverables in the project, while the project is to be fully completed. What is a PERT or CPM? So the CPM stands for Critical Path Analysis. PERT stands for Program Evaluation Review Technique. The distinction between the two methods has disappeared over time. Initially, PERT and CPM charts, they used to be two different charts. Over time, they have been collaborated, and now therefore they are called as PERT CPM chart. A PERT chart, or also known as a PERT diagram, is a tool used to schedule, organize, and map out tasks within a project. PERT, like mentioned earlier, stands for Program Evaluation Review Technique. It provides a visual representation of a project's milestone and breaks down individual tasks. An example of a PERT chart is given in the slide. We will be manually drawing PERT charts later in our face-to-face classes, and it will be looking something similar what you're seeing in the lecture slide. The boxes or the rectangles that are outlined by red marks, that represents the critical path. That means those paths are compulsory for the successful completion of the project. Now, a PERT or a CPM chart is also called a bottom-up technique. It involves project tasks, and once you know the tasks, their duration, and the order in which they must perform, you can calculate the time that it will take to complete the project. Like mentioned earlier, we'll get more familiar with PERT and CPM charts in weeks to come. Which type of chart is better? Although a Gantt chart offers a valuable snapshot view of the project, PERT charts are more useful for scheduling, monitoring, and controlling the actual works. This is where the advantages of PERT charts must be taken note of. So a PERT chart allows managers to evaluate the time and resources necessary to manage a project. Second advantage, incorporates data and information from multiple departments. Third advantage, improves communication during the project, and it allows an organization to commit to projects that are relevant to its strategic positioning. Fourth advantage, useful for what-if analysis. Understanding the possibilities concerning the flow of project resources and milestones allows management to achieve the most efficient and the useful path to successfully complete the project. Moving on. Identifying tasks in a work breakdown structure. So we have a task or activity. A task or an activity is any work that has a beginning and an end and requires the use of company resources such as people, time, or money. Event or milestone. An event or milestone is a recognizable reference point that you can use to monitor progress. For example, an event might be the start of user training, the conversion of system data, or the completion of interviews. Now, in work breakdown structure, we often break down the project into smaller tasks, creating a work breakdown structure. Identifying tasks in work breakdown structure. Now, the listing of the tasks can be challenging because the tasks might be embedded in a document. So to make it simple, we generally create a table with columns for task number, description, duration, and predecessor tasks. Using this information and the table, it becomes easier to draw the work breakdown structure. Identifying tasks in a work breakdown structure, estimating task duration, which is represented by D, duration. Now estimate the duration that may be undertaken to complete a task. Always try to overstate duration to accommodate possible scope creep or delays. Factors that affect duration may be the project size and scope, human resources, experience with similar projects, and constraints. What are task patterns? Large or small tasks depend on each other and must be performed in a sequence, not unlike the commands in a software program. Task patterns can involve dependent tasks, multiple successor tasks, and multiple predecessor tasks. A clear understanding can be built in our lab classes as to what are dependent tasks, what are successor tasks, and what may be predecessor tasks. How do I use task boxes to create a model? In a PERT or CPM chart, project tasks are shown in rectangle boxes arranged in the sequence in which they must be performed. Each rectangular box is called a task box and has 5 sections. Each section of the task box contains important information about the task, including the task name, task ID, task duration, start day or date, and finish day or date. Identify task patterns. That is step 2. What are the main types of task patterns? So the 3 main types are dependent tasks. Now, dependent tasks is when tasks must be completed one after another. Multiple successor tasks, when several tasks can start at the same time. Each is called a concurrent task. Multiple predecessor task requires 2 or more prior tasks to be completed before it can start. How do I identify task patterns? You can identify task patterns by looking carefully at the wording of the task statement. Words like then, when, or, and are action words that signal a sequence of events. Identify the sequence of the tasks using these connecting or connection words. What is a critical path? A critical path is a series of tasks which, if delayed, would affect the completion date of the project. If any task of the critical path falls behind schedule, the entire project will be delayed. Let's have a look at the example that is presented on the slide. Task 1 starts on day 1 and has a duration of 10 days. So the finish date is day 10. Task 2, which is dependent on task 1, can start on day 11, the day after task 1 ends. With a duration of 30 days, task 2 will finish on day 40. Tasks 3 and 4 are multiple successor tasks that can start after task 2 is done. Task 2 ends on day 40, so task 3 and 4 both can start on day 41. Task 3 has a duration of 5 days and will end on day 45. Task 4 has a duration of 25 days and will not end until the 65th day. Task 5 depends on tasks 3 and 4, which are multiple predecessors. Because task 5 depends on both tasks, it cannot start until the later of the two tasks is completed. In this example, task 3 ends earlier, but task 4 will not be completed until day 65. So task 5 cannot start until day 66. It has a duration of 30 days. Therefore, task 5 will finish off in day 95. So therefore, if we are to determine the critical path for this particular project would be task ID 1, task ID 2, task ID 4, and task ID 5. Therefore, in order to complete the project on time, this particular set of path or this particular set of tasks must not fall behind schedule. Otherwise, the entire project may be delayed. Monitoring and control techniques. The project manager must keep track of tasks and progress of team members, compare actual progress with the project plan, verify the completion of the project milestones, and set standards and ensure that they are followed. In the project lifecycle, the project monitoring and control phase happens in tandem with the execution phase. Project management monitoring and controlling involves actively reviewing the status of your project as it proceeds, evaluating potential obstacles, and implementing necessary changes. During this phase, organizations need to juggle several responsibilities, including keeping to the schedule, staying within budget, avoiding scope creep, and managing risk. Maintaining a schedule. Maintaining a project schedule can be a challenging task. The better the original plan, the easier it will be to control the project. Project managers often spend most of their time tracking the tasks along the critical path because delays in those tasks have the greatest potential to delay or jeopardize the project. This is where the importance of PERT charts are also realized in the project management phases. Reporting. Members of the project team regularly report their progress. Project status meetings to discuss project status, issues, problems, and opportunities. Project status reports. The diagram in the slide show members of the project team report their progress to the project manager, who in turn reports to management and users. A project status report is something that a project manager must report regularly to his or her immediate supervisor, upper management, and users. Should explain what you are doing to handle and monitor the problem. Most managers recognize that problems do occur on most projects. It is better to alert management sooner rather than later. Project management examples. PERT CPM example. You construct a PERT or CPM chart from this task list in a two-step process. Step 1, create the work breakdown structure. Step 2, enter start and finish times. Software-driven example, work breakdown structure, Gantt chart, and network diagrams. Gantt charts are often prepared and made in Microsoft Project. Network diagrams can also be formulated in Microsoft Project. Work breakdown structure, PERT, and CPM charts can easily be done in Microsoft Excel or in Microsoft Word or other specialized firm-oriented softwares. Risk management. Every IT project involves risks that systems analysts and project managers must address risk management. Steps in risk management. Some common steps may include develop risk management plan, identify the risks, analyze the risks, create a risk response plan, monitor risks. Depending on the nature and magnitude of the risk, the final decision might be made by the management. Possible magnitude of risks include low impact, low probability, high impact, low probability, medium impact, medium probability, high impact, high probability, low impact, high probability. Managing for success. Business issues. The major objective of every system is to provide a solution to a business problem or opportunity. A system that falls short of business needs also produces problems for users and reduces employee morale and productivity. The identification and shortcomings of these problems and opportunities must be resolved. The resolvement of these issues may lead to the successful completion of the project, hence success is managed. Budget issues. Costs overruns occurs in a system development process or project management. This is very much natural and is one of the frequent indicators of why a project may fail. What may allow costs to overrun? 1. Unrealistic estimates. 2. Failure to develop an accurate forecast that considers all costs over the life of the project. 3. Poor monitoring of progress and slow response to early warning signs of problems. 4. Schedule delays due to factors that were not foreseen. 5. Human resource issues, including turnover, inadequate training, and motivation. Schedule issues. Problems with timetables and project milestones can indicate a failure to recognize task dependencies, confusion between effort and progress, poor monitoring and control methods, personality conflicts among team members, or turnover of project personnel. These are some issues realized in the project management processes. So the bottom line is, when problems occur, the project manager's ability to handle the situation becomes the critical factor. Sometimes when a project experiences delays or cost overruns, the system still can be delivered on time and within budget if several less critical requirements are trimmed. Therefore, the experience of project manager can be a vital aspect. Moreover, staying ahead of the schedule can also be of great benefit. And finally, communication and teamwork is of something that is of vital importance. Lecture summary. Project management is the process of planning, scheduling, monitoring, and controlling and reporting upon the development of an information system. Project managers are responsible for project planning, scheduling, monitoring, and reporting. Planning, scheduling, monitoring, and reporting all takes place within a larger project system development framework. In project scheduling, the project manager develops a specific time for each task based on available resources and whether or not the task is dependent on other predecessor tasks. Every successful information system must support business requirements, stay within budget, and be available on time. Sound project management involves the same skills as any other management. This summarizes lecture 4, lecture 3. I hope this has managed to build some form of understanding, especially in terms of what all things that might take place in the project planning phase of system development or project development. Thank you.